Okay, just started recording. So today we'll learn about like how this hash map works and how actually it stores the data. So think that actually in order to store any data, all right, index-based approach is the best way. What is index-based approach? Index-based approach is something like your roll number, or index-based approach is something like um, your exactly these phone numbers and all. So in many places actually you will see uh, even the phone numbers, right? How it will in smartphones, yeah, in smartphones or anywhere actually we'll see that how it is categorized. So first actually it will, if you look at into your contact, uh, first actually it will store all, it will, you can see like alphabetical wise actually order. Maybe first you can see like a all A, all B, all C, all D, all E, all F, all G, right? So likewise, actually, what it means, it's actually categorizing all the names by looking at the first alphabet. So what starts with A, what starts with B, right? So even if you want, if you have like a many contacts, many numbers, how you will generally follow it? If you have a notebook, right? You want to store uh, all the phone numbers or all names actually. So what you do? You reserve actually one page for all A names, or another page for B, another page for C. So whoever is coming with that name, you will go and write into that one, right? Why you do that one? That gives you like a faster search. Like for example, actually you want to find where Madhuri is. You can quickly look M and then you can go with the rest of letters where it is. So the best search is, right, with the best search is with the index based approach. Even think about linked list versus array list. Which one is gives you like a best search capability?
Array list, sir.
Right, right. Array list, like let's say I want a fourth element. You just will go and read the fourth element because you index them. You put them like a where they want it. So let's look here. So you summarize here. Uh, right. This is your array list items. So just actually passing, get me uh, names of two. So what does this give? Hello. What
It will
does
give
this?
Madhuri.
Right. It give Madhuri. Right. So it results Madhuri. Why? It's like second index. That's what we are accessing. So if I want first, actually I can give like a number 5. So at the same time, actually linked list is the accessing is much difficult because actually it needs to traverse, right? So it needs to traverse like how it is stored. Sabah. So it comes up with two style. So it comes up with two for this one, right? First Sabha. So Sabha next is Kavya. So Kavya next is Madhuri. So what it has to do? It is corrected like this. So it has to when I want to when I ask like a giving second element. So what it has to do? It has to first actually start from beginning here. Okay. Then it will take. Okay. This is 0. Okay. I'm in 0 position. Next actually it will go here and it will increment the counter 1. Next actually it will go here and it will increment the counter 2. Okay, you are asking me the second element. Okay, take this Madhuri is your second element. That's how it will do. But whereas in index-based approach, you can directly get what it is. It just directly looking at your page number. Like let's say even just now Sabha shared screen, right? I just pointed some line number. So she can directly go to that line number. Otherwise, actually, if I say, okay, look at that if condition where it is, if it is saying that if condition switch statement, then she has to read the entire document of file, look up for the switch statement in which line it is there. If I directly give the line number, actually she can directly go there, right? So it is similar to that one. Okay, index-based approach is always faster. So that's where actually even HashMap came from. HashMap actually implemented the same logic. So in HashMap, right, every time it will store the values based on their index values, like how it will calculate the index values. So in HashMap, actually the concept is called everything is called like a node. What is node, right? It's similar to our linked list node. It's also a node where it will store first actually it has the hash value. What is the hash value? And bucket where it can store the bucket. Okay. And also a key value. Two things actually it has it. And a node to the next reference as well. So this is what actually it has that information. But bucket is actually something like I will say that it's not part of the it's not part of that one, but you can think that node key value. This is a reference to the next. So how it will store? Let's look into that. So if I say hash, right? So let's say I want to print a hash value. We already did that one. So let's say I want to print a hash value for Dakshayani. So we know that actually every string has, every object in Java has a hash value, no matter what, right? So what I'm doing, I'm just printing hash value of Dakshayani. So what it prints? Yeah, it prints this much. Going back actually, uh, going back here, if I want to put them like index based approach with in a linked list, I need to have this, like I need to give like ID for each and everyone. Let's say it's like a roll number. I told you, right? In you are registering into your new class. Everybody are employee. Everybody will be having their employee ID, right? Uh, so this ID represents Dakshayani for now. Okay, this ID represents Dakshayani. This represents Dakshayani. If I want store index-based approach, right, as roll number approach, I need to have these many numbers in my array, right? So something like uh, one maybe alpha guy for alpha. Okay. Similarly, I have similarly I can put like a. I'm just hypothetically giving that 999 beta. So likewise, actually, I need to have like a, if I want to call Dakshayani index, right? I need to have this much size of array list where random values like a array of one maybe alpha, right? I can easily cast actually. I can easily get that. If I say like a one, alpha will come. If I say like a this number, Andy will come. If I say this number, Dakshayani will come. So I need to have this type of numbers, but we don't have. It's impossible to store this much big numbers or this much to allocate this much uh, size of array, right? So it's something like, okay, I need to declare array string names equals to new strings of this much size to to store Dakshayani value. So there actually we are actually plus one, right? Here actually we can store uh, so here actually we can store like this, and same way actually I can access based on this one. So it's very difficult to store this much big size of arrays, and it's practically not possible. Okay, that's where the hash map came up. Hash map actually what it will do, uh, every hash map will be having only um, so HashMap came up the concept of simplifying this one into one of the 16 variables. Okay, so it is 0. Okay, as always we know it actually it starts with 0. Instead of storing into a big array list. It stores the capacity wise, it stores into 16 array elements. How it will store it? That's where we will know it. So our results are what we need to store. Say we need to store like what's the phone number, her phone number. Yeah, this is her phone number. Okay. Similarly, we need to store other people. Dharani. Okay. So these are my elements, right? I want to store them into HashMap. So how will I store it? Uh, so whenever I call, we already discussed this one. Map.put is the way actually you call this one. So you create HashMap. Here actually you create HashMap. New HashMap. Okay. You created a new HashMap here. And next one is you are putting the element here. So what you are doing, map.put, and then you are putting this is what actually you are putting into it. When you call this one, right, what it does, so when you call this one, right, what it does, it actually calls for a key, actually it calls a hash code. The hash code what we got is here, this number. But this number actually uh, we can't actually store this one, right? So using some algorithm, hash algorithm, it actually gets into uh, one of these one, like a module, this one. Let's say actually this value module is how much it is. So it's a 6, right? So it will go this value when you call this one, right? This will go. As I said, right, it has actually not only this one, Dakshayani, and also it will store the hash value. and next. What is next? So this value, right, it will go and it will store against 6. It stores in the 6th bucket. Okay. Now actually, let's say Dharani. We are calling Dharani. Let's see like what is Dharani uh, hash code. So it's like a minus value, right? So Dharani got like a minus hash code. So what it does, Dharani hash code is this one, and her phone number is value is this one. Okay. Now look at where Dharani can fit into. So let's take modulo. It goes into 9th element. So Dharani, when you call Dharani.put, right? When you call Dharani.put, it will go and it will put into here. Same, Kavya. So what is Kavya's hash code? Let's look into this one. So it is Kavya hash code is this one. Like hash code and all. Like where this can go? It goes into 8th position. Goes into 8th position here. Now Sabha. What is Sabha hash code? Yeah. 26. And where in which bucket actually she can go? 13th. So Sabha will go into 13th bucket. When you call like a put, Sabha will go into 13th bucket. Now let's say Smriti. What is Smriti hash code? It's again minus negative value. Let's so what is in which bucket actually it can go? It goes into 12th bucket. Likewise, actually it can store all the data that is appropriately it goes into this one. Now let's say I want to store another element. Let's see. What is the hash code for? I want to see like when hash code collision will happen. We don't have 14, I think. Right? Okay. We don't have. Yeah. So now I want to store one more element called coffee. Okay, which has hash code of this one. Okay, and phone number maybe coffee phone number maybe like that. This one. So now what happens if this one, right? This one is actually is colliding. If I say like a module of this one, it's actually giving like a 12. So in 12 already there is a element, right? So when you say map dot put in 12 already there is a element. That's where I said like a it's also hash. I stored something in a key. It's actually the representation a little bit differently. I gave it. First key coffee hash value. Okay, this one, and next one is uh, the value, right? And we also have the next node that's references to next. So it's something like each and every one will be having next node as well. Something like this, it will have associated with this one each. So these two type together. So what it will do, it will now actually from here, it will form a linked list. So this next is here. Likewise, actually, it will start giving the number. Now, right, when you are asking, this is okay. Now, when you say map.get, so same thing again, the same process it will follow. When you say map.get, what it do? It tries to first actually what is the hash code of this one. Hash code of this one is this one, right? So first actually it will execute the hash code of this key. So it came like a this value. It came like a this value where this will fall into the sixth bucket, and it will go. Okay, it will go and verify the hash code value now. Where in the sixth code in a linked list, where in the sixth code this value is equals to this one. So for example, like let's say actually I want to I want to read coffee. I want to read coffee value. So what it do? It takes this one, right? Hash code value here. Hash code value is 12. Bucket value is 12. So it will go here. It will verify. Okay. Now first element it will verify actually with this one. Okay. Is minus 417 is equal? No, not equal. It will go here. Is it equal? Yes, it is equal. Okay. So what they are asking? They are asking value. Okay. So return this to here. So it will return this value here. Whatever the coffee value we stored it will return this one. That's how internally it works in the Java. Sorry, that's how it works internally in HashMap. So all you need to remember, like there will be like a 16. Why they took 16? If you go into HashMap, Yeah. So the default initial capacity is 16. Why I took that one? You can take like anything actually. Like if you want to store any random values, you can take this into anything. Maybe you can give 30, 40, so that actually your hashing can store multiple values. But in this one, right, still there is a disadvantage. The disadvantage is like it's still going to like a linked list. My approach is actually to solve the problem uh, like where I will get a faster access. Okay. But although actually I'm storing key value pair for my purpose, but actually my data is actually stored again in the linked list, which is causing me performance problems, right? So that's where actually from Java 8 onwards, I think they removed this one, the linked list concept. They came up with a red block tree concept, which is nothing but a hash, which is nothing but a something like we learned about the binary tree, right? So exactly that's what it is. So what it does here, move here. So this one, right? Instead of storing like this, for example, instead of storing this one, what they will do, they will store like a red block tree. So let's say this one is black. Okay. So here, I mean, I'm referring to line logically, it's supposed to be at here in the 12. Okay. So this 12 is pointed here, right? So logically it is here, but I can't put everything here. That's why I'm keeping it here. So let's say this is in red color. Okay. So similarly, if anything again comes up with the same, right? So let's say this value is, it's not positive. I mean, hypothetically, I'm changing the values now. So it's like something like the left and right values. So let's say this value is 6,000, right? So where the left value will hold like a smaller value, right value will hold the higher value. Likewise, actually it will keep storing in a block, in a binary tree. So that's where actually you will get faster access than linked list. Okay, any questions on this hash map implementation?